Hello. I've made some changes to my original final project proposal. My original proposal proposed conditional immutability for a cryptocurrency, which I just don't think, it turns out I don't think it's very useful. So I decided to go with something more practical. So today I'll be presenting on how distributed ledger technology can enhance transparency and efficiency in fleet management. This project explores how blockchain systems can create trust, streamline operations, and reduce inefficiencies in the trucking and logistics industry. Fleet management involves a complex network of drivers, logistics coordinators, carriers, and clients. However, these stakeholders often work on different data systems, which leads to data silos, inconsistent reporting, and disputes about deliveries and maintenance records. This fragmentation results in lost time and money. According to the American Trucking Associations, the U.S. trucking industry moves over 11 billion tons of freight annually, valued at nearly $940 billion. Despite this scale, companies lose millions due to data mismatches, fraud, and delays. Manual reconciliation can take up to a week for a single shipment, which highlights a serious efficiency gap. DLT is a shared, synchronized database that operates across multiple participants rather than one central authority. It provides immutability, transparency, and automation through smart contracts. Sort of like a secure digital logbook that everyone can trust because no one can secretly alter it. DLT perfectly fits fleet management challenges. It makes maintenance and delivery data immutable, allows real-time verification, and enables smart contracts that automatically process payments. It removes the need for costly intermediaries while reducing fraud risk. Let's imagine a shipment monitored by IoT sensors. Each time the truck reaches a milestone, the sensor records data such as location, mileage, and cargo temperature. That information is stored on the blockchain, and once the shipment arrives, a smart contract automatically releases payment. This creates end-to-end trust between the driver, operator, and client. This architecture shows how the distributed ledger technology ties together every part of fleet management. It begins on the left with the IoT device mounted in each truck. These include GPS trackers, electronic logging devices, and temperature or cargo sensors. Each one captures live telemetry data about vehicle location, condition, and driver behavior. That data first flows into a secure edge gateway or API layer. This gateway normalizes data, filters out noise, and digitally signs each packet before sending it forward. The gateway also ensures that only verified devices are allowed to push data. From there, data enters the permissioned blockchain layer, which contains validator nodes run by the fleet operator, client, and regulator. Using a proof of authority consensus, these nodes agree on the validity of each transaction. This means all parties maintain identical copies of the delivery record. None can alter it later. Smart contracts on the blockchain evaluate incoming data. For example, when a GPS event shows that the truck reached its destination and the cargo temperature stayed within range, the smart contract automatically marks the delivery as complete. Finally, the fleet dashboards and partner systems, like ERP or regulatory databases, display real-time insights and compliance reports pulled directly from the ledger. Every stakeholder sees the same trusted data, eliminating disputes. The solution relies on four main components: smart contracts, consensus mechanisms, off-chain storage, and APIs. Smart contracts handle automation, proof of authority, ensures secure validation within a private network, and APIs allow the blockchain to connect seamlessly with existing fleet systems. While promising, the design does face challenges. High-frequency IoT data can overwhelm blockchains. Privacy rules require careful data handling, and integrating with older systems is not a trivial task. Additionally, compliance rules differ across regions, so data governance is critical. Improving off of the backbone of the original architecture, we can build scalability and privacy into the design. The architecture starts again with the IoT and edge aggregation, but now the devices send data to an edge aggregator that batches sensor readings and compresses them before transmission. This reduces blockchain write frequency and network load. Those batches move through a streaming ingestion layer such as Kafka or MQTT. This component guarantees message ordering, handles retries if connectivity drops, and prevents flooding the blockchain when hundreds of trucks send updates simultaneously. Next, data splits into two paths: the full dataset, telemetry streams, PDFs or images, goes to an off-chain data lake, while only cryptographic hashes of the data and key metadata go onto the blockchain. This hybrid design keeps the ledger lightweight while maintaining integrity. Any future change to the off-chain data would break the hash reference. On the blockchain itself, smart contracts now run more advanced logic such as service level agreement checks, and automated financial settlements. For example, when a shipment reaches its destination and all metrics meet the service level agreement check, the smart contract releases funds to the driver or carrier via the integrated payment layer. Above this sits an access control layer, ensuring that only authorized users can see sensitive data, followed by dashboards and APIs for clients, regulators, and finance teams. Finally, the system includes privacy and observability modules to manage regional data compliance and monitor overall system health. This makes the architecture enterprise-ready, scalable, compliant, and auditable end-to-end. The expected results are significant. Up to 40% faster settlements, 25% fewer disputes, and 20% less maintenance-related fraud. By recording verifiable data, DLT increases trust, accountability, and operational speed. Major logistics players are already exploring blockchain. IBM and Maersk created TradeLens to improve maritime visibility. CargoX digitizes freight bills of lading, and the Blockchain in Trucking Alliance, or BITA, is working to standardize DLT use in trucking. Looking forward, we can combine blockchain with artificial intelligence for predictive maintenance. Fleet operators could also tokenize insurance or track carbon emissions more transparently. Eventually, this technology could support multimodal logistics networks spanning air, rail, and sea. Distributed ledger technology creates a single source of truth for fleet management. It improves efficiency, accountability, and trust. Essential traits in modern logistics. DLT doesn't just improve technology, it transforms how the industry collaborates and shares data. Thank you.